Welcome to Sharina's World, and this is Sharina. Today we are going to handle the session decimal number systems. Decimal number system. We all are quite familiar of this number system because this is the common number system that we people use. So the information regarding the systems are the radix value is 10. Radix value of decimal number system is 10. So, as the base is 10, we can conclude two things from that, that is it is having 0 to 10 minus 1, 0 to 10 minus 1 number of digits, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Using these 10 digits, all other quantities are being developed. So, this is the basics of decimal number system, and again these are the basic 10 digits, and using this we can generate all other quantities. How big the quantities we can generate from these 10 digits. Next we will see the conversions of decimal number system. First we will see, given a decimal number, to convert it into any other number system with base r. Whatever be the number system, to convert a decimal number to any other base number system, we have to do, let the given number have two parts. The part before the decimal we term it as integer number system, integer number part, and part after the decimal is fractional part. So, for the integer part, we have to do repeated division by r till further division is not possible. And for the fraction part, we perform repeated multiplication with the fractions obtained. Repeated multiplication with the fractions obtained. We will see few examples for this. So, first we will try to convert a given decimal number into corresponding binary number system. Since binary number system, the number system into which we want to convert the base is 2. So, let us convert the number 38.25 to the base 10 into corresponding binary number. Okay, so 38 is the integer part. We have to perform repeated division by 2. So, take 38, repeatedly divide it by 2. So, when dividing it by 2, 38 remainder is 0 and 19 is the divisor quotient. Now, again repeatedly divide. So, here it is 9, remainder 1. Divide, again we can divide, so divide by 2, this will give you again remainder 1. So, divide the 4 by 2, this will give you remainder 0, and again we can divide, so 1 and again so remainder is 0. Now, that further division is not possible. Take 0.25 is the fraction part. For the fraction part, we have to perform repeated multiplication with the 2. So, 0.25 into 2 will give you 0.50. Again, take this fraction part, 0.50 into 2 will give you 1.00. So, this is the fraction part. Again, 0 into anything will give you 0 only. So, we can end it here. Now, that for this thing, we have to count from this to upward, from downwards to upward. That is 100, 110. This is the corresponding binary representation of the integer part, and again place the decimal point, and again for this we have to write it from upward to downward. That is only the integer part of this, that is 0 and 1, 0.01. This is how we can convert a given decimal number into corresponding binary number system. Similarly, Same steps is being followed when we are using any other number system. Only difference is the dividing term, the base value changes. So, now let us convert another thing, that is 96.375 to the, this is in decimal number system. We want to convert it into octal number system. That means we are going to divide 96 repeatedly by 8 and going to multiply 0.375 repeatedly with 8. So, 96 divided by 8. 96 divided by 8 will give you 12 and the remainder is 4. So, with 8 we can again divide 12. So, that is 1 and remainder is again 4. Sorry, this one is remainder 0 and so 140. Again we have to write from here to here, that is 140, and for 0.375 the fraction part we have to perform repeated multiplication with the base r, that is corresponding to 3.00. So, that with 0 again we have to perform it with 0 0. So, with 0 0 whenever we are adding anything, that will multiplying will give you only 0. So, we can end it here. So, that 0.375 is corresponding to 3. So, the final answer is 140.3 to the base of 8. That is the converted number. Next one, we have to convert a given decimal number into corresponding hexadecimal number. So, the given number is 523.71. 523.71. Take the integer part 523, repeatedly divide it with 16. So, when divided by 16 will give you the answer 32 and remainder 11. Again with 32 we can divide this, which will give you 16, and so the answer is 2. So, 0 is the remainder. Write it from here to here, that will give you 2011. 11 corresponding to hexadecimal number system is actually B. A is 10, B is 11. So, 20B is for the integer part, and take 0.71 out, repeatedly multiply it with 16. So, 0.71 into 16 will give you 11.36. Take this 36 out. 36 into 16 you have to perform it, which will give you 5.76. Take 0.76. 0.76 into 16, which will give you 12.16. So, take the integer part out, that is 11, 5, 12. 11 corresponding to hexadecimal is B, 5 is 5 as such, 12 is C. So, in total it is 20B point B5C corresponding to the hexadecimal base. This is how we convert a given decimal number into any other number system. Suppose we might be asked to convert a given decimal number into any base like 4, 3 or 5, something like that. Only thing we have to do is repeatedly multiply the integer part and repeatedly multiply for the fraction part and repeatedly divide for the integer part. Now, one more topic is there, important from decimal number system, as we all are quite familiar with decimal addition, multiplication, subtraction and division. I am not going into that, but a part left behind is r's complement and r minus 1 complement, r's complement and r minus 1's complement. That is, here r is 10, base is 10, so 10's complement and 10 minus 1, that is 9's complement. So, just like any other number system, here 10's complement is equal to 9's complement plus 1. 9's complement plus 1. So, to find out 9's complement, what we have to do is, actually we have to perform given number, subtract it from the corresponding largest number. An easy way for this is, write the base digits in ascending order. First, write the base digits of decimal number in ascending order, that is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Just below that, just beneath to 8, write in descending order. So that is 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Arrange so like this, that just below each number there is some other number. Now suppose we want to find out 9's complement and 10's complement of a number, let it be 536.421. This is a given decimal number. We want to find out the 9's complement of this number. Take the first digit 5. What? Place it in the first row. Here it is 5. What is written just below that? It is 4. Write it 4. Take the next number, that is 3. From this, take the number which is written just below that. It is 6. And next number is 6. Take the number 6 in first row, and what is written just below it? It is 3. Place the decimal, take 4. The number below is 5. Take 2. Number below is 7. Take 1. Number below is 8. So this is the corresponding 9's complement of the given number 536.421. And to find out 10's complement, what we have to do? We have to add a 1 to it. Add 1 to the last digit. Even if it is after the decimal, wherever it may be, the least significant digit, we have to add 1. Not one thing, not to the number, last number before the decimal. The last number of the given, last digit of the given number should be added with 1. So this will give you 975.364, 463.579. This is the 10's complement of the given number. I hope it's clear how to determine 9's complement and 10's complement of a given number. Next is subtraction using 9's complement and 10's complement. Subtraction using 9's complement and 10's complement. So I'll write down the steps. First one, find out the 9's complement of subtrahend. Find out the 9's complement of subtrahend. Second step, add the minuend to it. So it is minuend plus 9's complement of subtrahend. While adding, if a carry is generated, in 9's complement, add the carry to the sum. Add that carry to the sum obtained. What we have obtained right now. And if no carry generated, which means if no carry generated, again find out the 9's complement of the obtained sum. 9's complement of the obtained sum and give a negative sign. Give a negative sign to the sum obtained, to the 1's complement, to the 9's complement that we have generated right now. This is the steps for the 9's complement method. We will see an example for this. Perform a 9's complement subtraction. Suppose we are going to perform subtraction of 528 minus 327. 528 minus 327 using 9's complement. Using 9's complement method. So First determine the minuend and the subtrahend. This is the minuend and this is the subtrahend. So, find out the ones complement of the subtrahend. Ones complement of 327. 3 corresponding it is 6. 2 corresponding it is 7. 7 corresponding is 2. So, this is the 9's complement of the subtrahend. Add 528 with it. Add 528. This will give you 10. 1 carry. Again 10. 1 carry. So, this will give you 12. So, a carry is generated. When a carry is generated, you have to add this carry along with the sum obtained. So, 2, 0, 1. That is the corresponding difference we are supposed to obtain. This is the corresponding difference that we are supposed to obtain. Okay. Next, perform similar way. Do one thing. Try to do 327 minus 528. So that we interchange the minuend and subtrahend. Here 327 is the minuend and 528 became the subtrahend. So find out the ones complement of 528. 5 it is 4, 2 it is 7, 8 it is 1. So 471 is the 9's complement of 528. Add it with the minuend. So minuend is 327. This will give you 8, 9 and 7. 8, 9, 7. See here, no carry generated. Carry is not generated. When there is no carry, what we have to do? Again find the 9's complement of this sum. So 9's complement of 798 is 798, 9's complement. 7 it is 2, 9 it is 0, 8 corresponding to 1 and give a negative sign. So, negative of 201 is the corresponding answer. So, this is how we perform subtraction using 9's complement. Now, we will write the steps of subtraction using 10's complement. So, using 10's complement, how we will subtract? First thing is find out the 10's complement of the subtrahend. 10's complement of subtrahend. Add the minuend with it. Add the minuend with it. Second step, if a carry generated, which means actually the difference is a positive value. So, if a carry generated, ignore the carry, and if no carry generated, that means the difference is negative symbols, which means subtrahend is greater value. So, if no carry generated, find 10's complement of the sum obtained and add a negative sign to the sum. We will do an example, same thing. Okay, so 528 minus 327 using 10's complement. So, for that we have to find out the 10's complement of 327. And again, for obtaining 10's complement, it is actually 9's complement plus 1. So, first find out the 9's complement of 327. 327 corresponding 9's complement is 6, 7, 2. 672 plus 1 is 673 is the 10's complement. So, 528 plus 673, which will give you 11, 1 carry, 10, 1 carry, 12. So, a carry generated, what we have to do? Ignore the carry, ignore this, and the remaining 201 is the corresponding difference. Now, again we will do this using 10's complement. 327 minus 528. So, here it is the subtrahend. find out the 9's complement of 528. 9's complement of 528 is actually 5, it is 4, 2, 7, 8, 1. Now 10's complement is actually equal to plus 1 to this will give you 274. 472 is the 10's complement. So add this 472 with the minuend. So 327 plus 472 will give you 9. 7 2s are 9 and 4 3s are 799. No carry generated. Here no carry. When no carry is generated, again find out the 10's complement of this. So 799, first we have to find out the 9's complement of 799, which is equal to 7 is 2, 9 is 0 and again 0. 10's complement is equal to plus 1, that is 201. So obtain the 10's complement and add a negative symbol. So negative of 201 is the correct answer for the corresponding subtraction using 10's complement method. I hope it's clear to all how to perform 9's and 10's complement subtraction. The important question from this topic is actually to find out 9's complement and 10's complement of a given number, or else subtraction using 9's complement and 10's complement. This is the pretty most important part in decimal number system and also conversion, decimal number conversion into any other number system. These are the 3 set of frequently asked questions from decimal number system part. Thank you, and I'll add few repeatedly asked questions, type of repeatedly asked questions in the description along with this video. Do watch it, try to do it, and in the next video I'll give the solution for the corresponding questions. Thank you.